Welcome to this presentation on simulation of a generalized equation for innovation in complex adaptive systems. My name is Praveer Malik, and I head organizational sciences at Zappos.com. And I have created this paper with Professor Dr. Leon Pretorius from University of Pretoria, Graduate School of Technology Management, for the IEEE TEMSCON 2020 conference. In this presentation, I'm going to share the approach that we took in thinking about complex adaptive systems. I'll share the generalized equation of innovation at a high level that has been the basis of the Vensim simulation that we created. And finally, I'll share key simulation results and takeaways. Complex adaptive systems can essentially be thought of amongst the most resilient of systems. And examples of this are natural ecosystems, cities, countries, the internet, economies, amongst many other different systems. The common view to study complex adaptive systems is from the bottom up. And being from the bottom up, the system is viewed as consisting of a number of autonomous units that interact with each other. And this naturally gives rise to properties such as distributed control, connectivity, coevolution, emergence, unpredictability, amongst other similar properties. Our approach to study complex adaptive systems has been from the top down, and this gives rise to complementary properties such as implicit order, qualified determinism, and directional integrity that we believe are equally important in understanding the operation of complex adaptive systems as a whole. Our approach and development of the mathematical foundation has taken place over several years, starting with a base paper on equations for innovation in complex adaptive systems that we presented at EMOT 2015. At a presentation also at EMOT in 2016, we presented a mathematical model of sustainability of any complex adaptive system based on the equations for innovation. And in 2017, at the TEMSCON conference, we presented a mathematical model to balance emergent unpredictability with directional integrity of complex adaptive systems. At TEMSCON 2018, we presented emergent mathematical operators to manage innovation in any complex adaptive system. And last year at TEMSCON 2019, we presented a mathematical structuring of the periodic table based also on our model of innovation in complex adaptive systems. This year, we present a simulation of a generalized equation of innovation. And this equation of innovation is based on essentially perceiving time and space as having implicit properties. These implicit properties is based on work that I have done previously and serialized as a number of books on fractals. And in this basic view, since time and space are perceived as having natural patterns existing in them, the causal framework for any organization bound by time and space has to be thought of differently. Essentially, in time, through the play of time, there's a particular maturity that can take place, and this maturity is summarized as going through phases that are called physical, vital, mental, and integral. And in space, there are considered to be different distinct sources of innovation that are summarized as being, or rather belonging to a set of presence, power, knowledge, and harmony. As a result, when we think about innovation in complex adaptive systems, they are really a combination or a play of these different implicit properties that exist in both time and space. and is summarized by this generalized equation of innovation. There is a default level of operation of any complex adaptive system, which Professor Dr. Leon Pretorius and myself, in the series of papers that we presented, have classified as being untransformed. And due to the changing or breaking of habitual patterns that exist at this untransformed layer of operation, a system can begin to operate at a meta level or tap into sources of innovation at a meta level, which we call meta level 1. And such sources of innovation tap into deeper, unique signatures or seeds that exist behind the untransformed layer of operation. In breaking further patterns that exist at these levels of uniqueness, a system can tap into another source of innovation that essentially has to do with implicit elements along the dimensions of presence, power, knowledge, harmony that can be mathematized as large sets of innovative sources. When breaking patterns that exist in the operation of the sets of innovative sources, a system can then be thought of as becoming further innovative by integrating the different elements that exist across these separate sets and thereby enter into a meta level 3 basis of operation. As a result of these patterns that play through time and space, there's a natural evolution in systems that takes it from this untransformed level to a relatively transformed level. And in the mathematics that we've already developed, we suggest that the transformed level becomes then the basis of a new series of equations in which it is the foundation of what's considered to be untransformed that then becomes further transformed. Now, we've summarized that basic notion of causality of any system bounded by time and space, and particularly of any complex adaptive system, as this Venn model in which there is a default layer of operation. And in this default layer, there are sources of innovation that derive from the 4 sets of present, power, knowledge, and harmony, but they exist in an untransformed, unregenerated nature. And that can only allow a system to avail of a certain level of system innovation. However, when certain patterns are broken that are modeled as levers that increase stocks in these different patterns of, or rather families of innovation, then a system can break into a meta level 1 basis of operation. And when further the patterns that typify level 1 basis of operation, the meta level 1 basis of operation, are broken, again modeled as levers that influence stocks at meta level 2, then a system can break into the meta level 2 basis of operation. And further, when these patterns that make a system operate just based on a pattern of innovative sources is broken, then a system can essentially avail of cross-pollination between these different sources of innovation that allows it to essentially operate at a meta level 3 basis of innovation. So when an organization operates at this meta level 3, then the overall system innovation can be much higher. And in simulations that we performed over a period of 10 years, where innovation contribution changes on a monthly basis, we find that at the untransformed level, where we have a number of negative sources of innovation active, the system can naturally increase its innovation up to 15 times over 10 years. However, when certain physical patterns are overcome, there's a substantial increase in innovation by 47 times, so that an innovation can, as per the base level, operate at 700 times the level of innovation. And then subsequently, as more and more patterns are overcome, in this simulation over 10 years, that same organization can hypothetically increase its level of innovation by 18,000 times. Basically, what our research indicates is that the way that we think about innovation contribution can be further refined, because currently we have innovation contribution that exists as a specific rate of change per month, that is 1 unit for metal level 1, 2 units for metal level 2, and 3 units for metal level 3 per month. But by instituting a system of causal balancing feedback loops in Vensim, it's possible to alter this contribution, this innovation contribution per month, based on the degree to which metal layers become active in a system. There's further scope for research in that we need to perform sensitivity analysis to alter the relative change to innovation contribution per month at successive metal levels. Importantly, this paper baselines the innovation multiple that is possible, provided negative organizational patterns are changed to positive organizational patterns. And that's summarized in the table that we had displayed on the previous slide. And interestingly, even if the sources of innovation remained untransformed, in this model, we see over a basis of 10 years, a potential increase of 15 times in innovation. So that gives us insight into if an organization is operating even randomly as a complex adaptive systems, we may expect its level of innovation to increase by 15 times. That said, an organization that fails to innovate, so as measured by common increases in business metrics of growth, such as revenue, market share, amongst others, it suggests that an organization is perhaps not operating as a complex adaptive system. So if there's not this baseline increase in 15x of innovation over a 10-year period, then that becomes the basis for suggesting that the system is not a complex adaptive system. So such a simulation really therefore provides insight into organizations that may be operating as complex adaptive systems and into the massive increase in innovation that is possible if certain conditions are fulfilled, essentially allowing these implicit patterns that exist in time and space to unveil themselves or become active through conscious actions, such as changing negative sources of innovation into positive sources of innovation. Thank you.